Hi, I'm Mini. Today I'm going to explain the topic hybrid model. Actually, BJT amplifiers. What is amplifier? It's a device, right? It's used to increase the magnitude of input voltage or current. Okay, that is what amplifier. In small signal model, if the input is very small, some fluctuations occur in the output. That we say about small signal model. Okay, so when we say zero signal or no signal, if no signal, that is if you are not apply any DC voltage, okay, we can say that is zero signal or no signal. Okay, now in amplifiers, so BJT is act as an amplifier. Okay, BJT, what is BJT? Bipolar junction transistor, right? In bipolar junction transistor, three three configurations are there: common base, common emitter, and common collector. Among these configuration, common emitter is act as an amplifiers. Okay, now for BJT amplifiers, some biasing resistors are used. For what purpose we are using this biasing resistor? In order to operate the transistor in the active region or Q point or the fixed point. Okay, so if it is not fixed, it goes under saturation region or that is what cutoff region. Okay, so if it shift saturation or cutoff region, we may get clipped output. Okay, that's why biasing is needed. And while analyzing the BJT amplifiers, these hybrid parameters and pi parameters are very important. Okay, for analyzing, so one transistor and with biasing resistors, biasing, so many biasing techniques are there: fixed bias, collector to base bias, voltage divider bias. Generally we are used to this voltage divider bias. Okay, so that biasing having more advantages among all the others. Okay, so in these biasing resistors and transistors are coupled through the coupling capacitor. Okay, using the coupling capacitor, the input signal or source voltage and series resistors are connected in the input, and through the coupling capacitors the load resistor is also connected, and through the emitter resistor we are used that bypass capacitor. We named that bypass capacitor as a CE capacitor. Okay, this is the introduction about the BJT amplifiers. Actually, why we are used this common emitter as amplifiers? Because in common emitter, its current gain and the voltage gain and also power gain, everything is high. Okay, so due to this we can implement this as amplifiers. Okay, for common collector, this current gain is large, voltage gain is unity, but the power gain is approximately equal to current gain. Okay, but in common base the current gain is small and the voltage gain is large, the power gain is approximately equal to voltage gain. Okay, these are the basics of BJT amplifiers. And now we explain the topic hybrid. Now we go under the hybrid parameter. Okay, in this hybrid parameter, see, uh, it's a two-port network. We can say it's a two-port network. Why we are saying this amplifier as a two-port network? Because here two ports are there: input port as well as output port. Okay, input port is what we can say, the input as we indicate that as 1 or I. Okay, but in output we will indicate that as out 2 or output. Okay, so what are the characteristics of a signal? Mainly two characteristics are available. The first one is current and the another one is voltage. Okay, voltage and current, these are the main characteristics which is present in the amplifiers. Okay, now here we are choosed that independent variables. Okay, v1, v2, these are the voltages which will present in the input and output port of amplifier. What about the next one, i1 and i2? This is the basic model. See, from this picture we understand v1 and v2 are the voltages which present in the input and output of the amplifier, and i1 and i2 are the current which will present in the input and output of the amplifier. Okay, now first we should know how to write the voltage current equation. Okay, the h parameters, what are the h parameters? H11, H12, H21 and H22. What are the hybrid parameters? H11, H12, H21 and H22. Okay, these H11 is the it's the parameter present in the input port, so we can say that H11. What is H12? We can say the one to was reverse. Okay, so reverse h parameter. Then h21, that indicates that forward h parameter, and h naught, it's the output parameter. Okay, then how will you write the voltage current equation? We are choose that independent variables v1, i2, and we can write the equation using the independent variables. First we write the v1 is equal to h11 into I1 plus h12 into V2. Similarly, I2 is equal to h21 into I1 plus h22 into V2. Okay, this is the basic model used in hybrid parameters. How to draw the diagram in this h parameter model? uh, it seems like the h. Okay, that's why we can say it as a h parameter model. Okay, so in input side one resistor and voltage source is there, and the output side the current source and parallel resistor is there. Okay, now we will draw the diagram. First draw the we know how to represent the voltage. The voltage is placed between two terminals, right? So first draw the voltage, then next first draw the voltage. Okay, that is what we want. See the picture, you understand. Next, continuously you draw the resistor, because see the current voltage equation, v1 is equal to h11 into I1, right? The h11 is the resistor. We can place that resistor there. After that, through the resistor I1 current is passed. Okay, then series with that we indicate as plus, and series with h12 into v2. What is h12 into v2? It's the reverse voltage gain. Okay, so reverse voltage, which voltage? Output voltage. That's why h12 into v2. Okay, continuously now we completed the input side. uh, now we consider the output port as what is that output port? Forward current gain. Here one source is there, that is forward current gain. H21 into H21 into input current. What is that input current? I1. Through this I2 current flows, and continuously we draw the resistor H22, that becomes output, which is the in output side the output voltage is V2. Okay, then how will you find the H11, H12, H21 and H22 parameters? H11 is, what is that? It's the, we can represent, it's the voltage resistor. Okay, R equal to V by I. Using the relation we will write that H is equal to V by I. Then H11 indicates that input as well as output both port is 1. Okay, that's why V1 into V1 divided by I1. What is H12? The input is the port 1 and the output is in second port. Okay, that is H12. It's the voltage gain. So we will represent the input as well as voltage output both will be a voltage. voltage gain is defined as the ratio of output voltage to input voltage. This is the general formula for voltage gain. But here reverse voltage gain. That's why V1 by V2. And H21, what is H21? It's the forward gain, forward current gain. That's why H21 is equal to I2 divided by I1. And H22, it's the output resistor. Both 22 indicates both will be the output port, so V2 divided by I2. Okay, so similarly using this model we can apply the common base, common emitter and common collector configurations. Okay, this is what common base configuration. See, sorry, common emitter configuration. What is that common emitter configuration? First draw the symbol of the common emitter. Okay, so how will you draw the common emitter symbol? We know that, right? Three terminals are there: base, emitter, collector. The emitter should be grounded. We will apply the input as base and the output as collector, right? Okay, so from the basic symbol itself we will drawn or we will understand the V1 I1 as input and V2 I2 as output. All the one are replaced by base and all the two are replaced by collector. Okay, then we will write the current voltage equation. Here also we choose the what independent variable V1 and I2. Here the V1 indicates that VB and I2 indicates that IC. Same configuration H11 into I1, right? Instead of H11 into I1, now we will represent H11 as HIE because H1 indicates that input and this is the emitter configuration. That's why HIE into IB. Okay. Then series with reverse. H12 is reverse, no? HRE into VC and I2 is what? IC. Okay. H21 is what? Forward. HFE into input current, that is IB. And HOE, that's the output resistor and its voltage is VC. Okay. Now we will draw the diagram. So see the diagram. This is the diagrammatic representation of what common emitter H model. Okay, so I think you all understand. Next one, next we move it to common base. Same procedure. First we will concentrate the symbol of the common base. For common base, base is the base is common, so base is grounded. We will apply the input in the base and apply the output as where collector. Okay, take the output from collector, apply the input to emitter and take the output from collector. Okay, same procedure. Now from the basic current voltage equation we replace all the 1 by emitter and all the 2 by collector. Okay, so we will easily form the voltage current equation. Here what are the independent variables? VE and IC. Okay, V1 as VE and V2 as I2 as IC. Okay, then how will you write the equation? How will you write the equation? VE is equal to HIB into IE plus HRB into VC and IC equal to HFB into IE plus HOB into VC. Using the equation, we can easily draw the diagram. Initially, V is there, right? So, we know how to draw the voltage between two terminals. Then continuously HIB, it's the resistor flowing through the current IE and finally um, then that is the reverse voltage gain, output voltage gain and combined with the output, that is forward current gain and through the main current is IC in the output side and parallel resistor is HOB, its output voltage is VC. Okay, next. Okay. Now common collector. Similarly, same procedure for applying the common collector also. First draw the symbol. See, draw the symbol of common collector, and we are choosing the two independent variables as VB and IE. We will write the current voltage equation as VB and IE. VB equal to what? HAC into IB plus HRC into VE, and IE equal to HFE into IB plus HOE into VE. Have you apply these equations using the basic current voltage equation? You replace all the 1 by B and all the 2 by E. Okay, so using the current voltage equation, we will form the H parameter model. So this is the H model. Okay, now one of the example how to draw the common emitter amplifier using this H model analysis. Okay, so some guidelines are there. First, draw the actual circuit diagram, then replace all the coupling capacitors by short circuit, and replace supply by short circuit, and mark the place of emitter, base, and collector. Then replace the transistor by its H parameter model. Okay, so this is the diagrammatic representation of common emitter amplifier, right? First draw the symbol with biasing resistors. Okay, so as I explained earlier, what is the purpose of biasing resistor, right? Then why we are choosing this common emitter as an amplifier. Okay, now we will couple the source voltage and source resistor by using the coupling capacitor C1 and our load resistor using the coupling capacitor C2. Okay, so okay, see the diagram. So what is the first step? Draw the actual diagram. So from the last slide, we drawn the actual circuit diagram. Okay, in this next step, replace all the coupling capacitors by shorting. Okay, by shorting, we will get the diagram like this. See the first diagram. Only R1, R2, RC and RL resistors are present. So what about the RE resistor, emitter, bypass capacitor? Okay, so it's the actually C1, C2. What is the purpose of C1 and C2? It block the DC and allow the AC. If you are not connecting C1 and C2, allows AC signal, right? AC signal as well as DC signal. But CE provide low reactance path for the output signal. If you are taken out the bypass capacitor C, there is no effect of RE resistor. So no need to connect the RE resistor here. Then you for drawing the H model, take out the all supply and ground. If you take the supply and ground, the other end of R1 and RC is connectionless, right? So it will turn it to the another end as grounded. Okay, one end is through the base or collector, and the another end is grounded. Okay, now next, we will combine this R1 and R2 as RB also, okay, because both resistors are parallel to each other, as well as in the output side RC and RL that also parallel to each other. So we will combine that. Okay. Next, transistor symbol. First draw the voltage source series with the resistor. Then the input voltage. Finally, we combined all the input resistors R1 and R2. Next one, H model. Using the H model, we use the common emitter H model. We already discussed that how to draw the common emitter. H model, isn't it? So employ that H model instead of transistor symbol. Remaining all the resistors are connected as it is. Next, small midband analysis of various types of single stage amplifier. Okay, first draw the two-port network. Then using H model, we will redraw the amplifier structure. Okay, first we will find the current gain. What is the general formula for current gain? Output current to input current. Here we will write the output current as two ways. Okay, if you consider the load IL by I1. If you are not consider the load, or if you consider the output port, it will be I2. So both will be opposite direction. So minus I2 by I1. Okay. This is take this as equation number 1. Then how to find I2? We will want the value I2. So through the voltage current equation, we choose the independent variable no V1 and I2. That I2 equation take it here. Okay. Or otherwise from the circuit diagram, we can easily identify I2 is equal to I2 and same direction the current flow HF into I1, then series with HO into V2. Okay, from the second step, what is V2? The general formula V equal to IR, right? So IL into ZL R minus I2 into ZL. ZL or RL both will be same. Okay, now substitute this V2 in I2 equation. I2 is equal to HF I1 minus HO into I2 into ZL, right? Now apply this in AI equation. Okay, I2 divided by I1 is equal to HF divided by 1 plus HO into ZL. The current gain A is equal to minus I2 by I1. Directly you substitute and find the value. Okay, uh, this is the way you will find the current gain. Okay, the next one is input impedance. First write the general formula for input impedance. What is it is equal to V by I. Okay, what is the formula for finding V? V equal to, this is also taken from voltage current equation. V1 equal to HI1 plus HR plus V, HR into V2. Okay, um, same procedure. Here also we will find the V2 value. How will you find V2? V2 is equal to minus I, that is IR, V equal to IR, the general formula. Using the formula we will write. Now we should include the AI in this step. That's why we will take minus I2 as, we know that, right? A is equal to minus I2 by I1. No, using I minus I2, V2 is equal to AI into I1 into Z. Substitute all the values. Okay, we will find the value Z. Z is equal to HI plus HRAI into ZL. Okay. Now the next one is voltage gain. How will you find voltage gain? The output voltage gain is the ratio of output voltage to input voltage, and the output voltage V equal to we know that V2 is equal to AI into I1 into ZL. Now substitute the value and find the value of AV. Then next one, output admittance. We will consider the input as impedance and the output as admittance. Okay, we know how to represent admittance, right? Y naught. Y naught is equal to I by V. Okay, so I2 is equal to HF into I1. This is also taken from voltage current equation. From this equation, substitute this Y naught is equal to I2 value. HF into I1 divided by V2 plus H naught into V2 divided by V2. Okay, now in order to find why not, we apply the KVL to the input side. Okay, so apply KVL. You know KVL is rise equal to drop. Okay, or sum of all the resistors is equal to 0. Vs is equal to I1 Rs plus HI into I1 plus HR into V2. Okay, the Vs value is 0.